The continuous random variable x has cumulative distribution function given as shown just here. Remember, the cumulative function, f of x, is the probability of x being less than or equal to x. In part A, we want to find the exact value of the median of x. So if we have some sort of shape like this, we're after the value such that the probability either side is 0.5. So we can just do that by substituting m into here, 1.5 m minus 0.25 m squared, take away 1.25 is equal to 0.5, and then we have a quadratic. We've got negative 0.25 m squared plus 1.5 m, take away 1.75 is equal to 0, and we can solve that probably by using the quadratic formula, or perhaps you have a feature on your calculator that can do that, and you'll find that m is either 3 take away root 2 or 3 plus root 2. Now if we look at the domain for this, it is from 1 to 3, so we can eliminate that one. It is out of the domain, and the value must be 3 minus root 2. We now want to find the probability that x is less than 1.6, given that the probability is greater than 1.2. So the probability of x being less than 1.6, given that x is more than 1.2, just using the conditional probability formula, is the probability that x is between 1.2 and 1.6 divided by the probability that x is more than 1.2. So, since we have the cumulative function, that is just f of 1.6 take away f of 1.2 divided by 1 take away f of 1.2. Remember, f of x is equal to the probability of x being less than or equal to x. And so with this one being a greater just here, that means we can use the 1 minus. And all of those values just can be substituted into here and evaluated. So it is just a case of putting it into the calculator, and you'll get 32 out of 81. Now this next part of the question is genuinely quite tricky. Or at least the way I did it, it ended up being quite tricky. So let's have a think about this. So we've discussed a couple of times that f of x is equal to the probability of x being less than or equal to x. So we're having the random variable y, which is 1 over x, and we want to find the cumulative distribution for y. So it should be clear that f of y is just going to be the probability that y is less than or equal to y. It's exactly the same statement as above, but with a different variable. Now we can use this substitution. F of y is the probability that 1 over x is less than or equal to y. Now we should be able to just do some algebra. All of these things are going to be positive. So we can say, well, that means 1 over y is less than or equal to x. And of course, we should have flipped those. That should be a y now, like so. And so we have that. And that means that f of y is the probability that x is less than or equal to 1 over y. And that means that f of y is 1 take away the probability of x being less than or equal to 1 over y. And that is 1 take away f of 1 over y. Now we're finally at somewhere that is useful. You may have been able to shortcut that whole process there, but that means that we can actually go up and look at the cumulative function here and think about f of 1 over y. Well, there's nothing too complicated about that. We've just got 0 and 1 over y is less than 1. And then we've got 1.5 times 1 over y. Take away 0.25 times 1 over y squared. Take away 1.25, and that will apply for values of 1 over y between 1 and 3, and then 1 for 1 over y greater than 3. So let's play with these a bit. So that's going to give us 0 for y greater than 1. So it's just a case of rearranging that. We'll have the 1.5 1 over y, take away 0.25 1 over y squared, take 1.25. That's going to apply, if we think about this one here, for y being greater than or equal to 1/3 and less than or equal to 1. And then we'll have 1 for y is greater than 1. Now, we know that we had a 1 minus over here. Fy was 1 take away f of 1 over y. So f of y is going to be, I just noticed a slight mistake up here. This one here, when we change that one, is going to be 1/3. Now for this f of y, we're doing 1 take away all this stuff above here. So we're going to have 1 take away 1. That's going to be 0. So the bottom row here is going to end up being the top row of our next table. And so that is going to be just spotting a second mistake, which I'm just going to correct. That inequality is the wrong way round. So remember that came from here. So the y would go up here, the 3 would go over here, and the crocodile's mouth would then face the 1/3 rather than the y. So now we've got that correct. So we're doing that row, but we're doing 1 take away that row. So 1 take away 1 is 0, and that is going to be for y is less than 1/3. If we look at the top row now, 1 take away 0 is 1, and that's going to apply for y more than 1. And if we do 1 take away the middle row, that's only really going to affect the negative 1.25. 1 take away negative 1.25 is going to be 2.25. So 2.25. And that will be take away 1.5 1 over y plus 0.25 1 over y squared. and that will apply for y in between 1/3 and 1. So it's fairly tricky, that part of the question. Part D sentence, hence or otherwise, find the mode of y. It's a bit mean really, because if you didn't get the last part of the question, these 3 marks are very difficult to get. So let's think about what the middle row became for y. I'm just going to call that P of y. And it was 2.25 take away 1.5 y to the negative 1 plus 0.25 y to the negative 2. Now, we know that this distribution went between 1/3 and 1. We don't know what shape it is. Let's just assume it's that shape. The mode is going to be the top. So we're trying to find the maximum there. Now, this bit is the cumulative function. So to get the PDF, we need to differentiate that. And that is going to give me 1.5 y to the negative 2, take away 0.5 y to the negative 3. So that's the PDF. We want to find the maximum of that, so we're going to need the second differential of p because it's the first differential of the PDF. So that's negative 3y to the negative 3 plus 1.5 y to the negative 4, and we need that to be equal to 0. So what we have there is 3 over y cubed being equal to 1.5 over y to the 4. That gives us 3y is equal to 1.5. Y is equal to 1.5 divided by 3. So y is 0.5.